Hello, welcome to lesson 1.1.2. Today what we're going to talk about is key points on a graph. So first we want to understand how to graph a function, and then we're going to talk about how to identify the key points on a graph using appropriate notation. All right, so yesterday we talked a little bit about a function. We learned how to put things into a function and get things out. We also looked a little bit at like what if I gave you an output and got an input. So today we're gonna take that function from its symbolic state with the equation, and we're gonna take a look at it in its graphing state. Right. So what does it look like on a graph? Okay. So to explore this, the first function we're going to look at is, we'll write this down here. We got the square root. We're going to do a square root function of x plus 2, and then outside of the square root, I'm going to put a minus 1. Okay, so we're going to be looking at this function right here. And then we're going to generate some inputs and outputs. All right, and we're going to do this the easy way using our calculator. So rather than going through and just putting an input in, calculating, seeing what we get for an output to generate our table, we'll just let the calculator generate all of our inputs and outputs for us. Okay, so I've got my calculator over here, and hopefully you've got a similar one on your Chromebook from the link that I provided on the class page. What you're going to do is you're going to hit the y equals button, and this takes you to the equation screen, and this is where you can enter in your function. Okay, so for future reference, the y1 that you see on the calculator screen is the same thing as f of x. It means the same thing. Okay, so all I have to do here is enter in the right hand side of the equation, the rule of the function. All right, so I'm going to enter in a square root. I'm going to hit second, and then x squared gives me my square root, and I'll type in x, so this is our x button, plus 2. And then to get out of the square root, I hit the right arrow, and then I'll type in that minus 1 on the end. Okay, and then I can go ahead and hit the graph button, and I'll see my graph pop up here, right? So you can kind of see this curved line right here. That is the graph of my function, the square root of x plus 2 minus 1. Okay. Now for me to get a graph over here on my paper, I'm going to start with the table. So I want to go and get some values from my table to write down. And so if I hit second graph, you'll notice table's in blue. So I hit the blue button and then graph. And then I get a table of values already generated for me. And I can go up and I can take a look at some of the negative values for x and some of the positive values. So you always want to kind of go back from 0 and make sure you get some of the function that's going to be over here and some of the function that's going to be over here. Okay, you'll notice where it says errors, if you keep going up, it'll say error forever and ever. So we're going to start here with this -2 and -1. So I'm going to come over here and I'm going to write that point down. So x is -2, and then f of x, or y, is going to be -1. And I'm going to jot down those points. All right, I'm just going to start there. So I got -1, 0, I got 0, and we'll just go to 2 decimal places here. So 0 and 0.41. And then 1 and 0.73, 2 and 1. And then I'm going to skip ahead a little bit here and grab one more point. But I want that last point that I get to be a point that's got integers in it, so no decimals. So I'm just going to skip over these few, and I'm going to go right to 7, 2. Okay? And that's really all I need. I just need a few points to put on my table, so that way I can take those points and plot them on my graph. Okay, so I'm going to start with this first point, -2, -1. So here I am at my origin. I'm going to go left 2, down 1. And I'm going to plot a point. And then I'm going to go to this one, -1, 0. So left 1, and I'm not going to go up or down at all because the y-coordinate is 0. The next one is at 0 and 0.41. So I'm not going to go left or right at all, but I got to go up 0.41. So I just got to eyeball it a little bit here. So about right here. Right, so if you get one of those decimal values, you're going to be in between the box here. You just got to eyeball where you think 0.41 is. It's almost halfway, but not quite halfway. This next one is at 1 and then 0.73. So I'm going to go right 1. Oops, didn't mean to draw that. So I'm going to go to the right 1 and up 0.73. So it's more than halfway this time. So I'm going to say about right here. And then we've got 2, 1. So I'm going to go right 2, up 1, and I get a point right there. All right, and then this next point, 7.2, right, it's going to take me a little bit to the right. So go 1, 2, 3, 4, 5, 6, 7, up 2, and there's the last point that I got on my table. And you can kind of see I'm gonna draw my curve through those points to get a graph that was similar to what I had on my calculator. And I really suck with drawing this pen, all right, so don't make fun of me here. So I'm going to go, hey, that's not too bad. So just like that, all right, so I started here at this point, and I went through my points that I plotted trying to draw a smooth curve, and I made sure I put an arrow on the end to indicate that this thing keeps going on forever and ever and ever. All right, and I'm going to check it on my graph, right? So you can see it looks very similar to what I drew over here, which is great. And notice that it doesn't keep going in this direction. That's why I did not put an arrow over here. All right, so now that we've got a graph and a table, right? That was our first mission, was just to be able to graph something. Now that we've got a graph and a table, I want to make sure that I can identify my key points on the graph. All right, so this first one here, the x-intercept, and I'm going to grab my highlighter. So the x-intercept occurs whenever we cross the x-axis, right? So this is our x-axis right here, the horizontal line that runs across the graph, and we're looking for where the graph hits the x-axis, and it hits right here. Right? You'll see I highlighted that point. That is our x-intercept. That's where the graph crosses over that x-axis. Okay, so let me grab my pen again, and I'm going to write that point down as my x-intercept. Oops. There we go. And that point occurs at -1, 0. Okay, so when they ask you for an x-intercept, make sure you write your x-intercept as a ordered pair, because it is a location on a graph. Okay, so I'm going to grab my highlighter again, and this time we're going to find the y-intercept, so we're looking for where the graph crosses over the y-axis. That happens right here, right? So our y-axis runs up and down through the center of the graph. So the graph crosses that line right here, and I'm going to grab my pen and write down that location. Okay, and that location is at one of the decimal values. It's actually this one right here, 0.41. So I'm going to say 0.41. And notice that the x-intercept occurred when y is 0. So this can be another way of finding this, right? So x-intercepts occur when y equals 0, and the y-intercept occurred when x equals 0. Right? And that makes it easy to find in the table. You can see our x-intercept here at -1, 0, and our y-intercept here at 0.41. Right? Now the minimum, right, this next point that they're talking about, the minimum is the lowest point on the graph. Okay, and that is going to happen, let me grab my highlighter again. Right? That is going to happen here, right? So if we're talking about high to low, the lowest point that this graph gets to is right here, doesn't ever get any lower than that point. Okay, so I'm going to write that one down, and that point occurs at -2, -1. Now the maximum would kind of like the minimum, but it's the highest point on the graph. And if you look at our graph, you'll notice this thing keeps going forever and ever and ever, which means it's going to keep going up forever and ever and ever, which means it's never going to reach a highest point. All right, so that would mean that there is no maximum. We would say none for maximum here, or on MyOpenMath they might have you type in DNE, does not exist. Okay, so those are your key points that we're learning about today. The other thing that I want to talk about is something called the axis of symmetry, but we're going to come back to this. It's easier to talk about the axis of symmetry with something that actually has symmetry, so we'll do that first, and then we'll come back to this problem and talk about the axis of symmetry on this graph. All right, so let's take a look at one more function, and we'll practice graphing. Okay, so our function that we're going to work with for this one is going to be x minus 3 in parentheses and an x minus 7. All right, so we're going to do x minus 3 times x minus 7, and we're going to go to our calculator, clear out whatever you have there in y1, and type in your new function. And this time I'm going to go straight to the table. So I'm just going to hit second graph. I'm going to go straight to my table, and I'm going to look at my table to grab those values. And I'm going to go down. My graph that I've provided over here doesn't go past 10 or negative 10, so I'm looking at my y values and I'm noticing it goes up to 12 here. So I'm going to start here at the 2, so 2, 5, and I'll grab all of the points that I can that have a y value that's smaller than 10 and greater than negative 10. Okay, so you'll kind of see it starts there at 2 and ends at 8. So I'm going to grab all the points from 2 to 8. So I got 2, 3, 4, 5, 6, 7, 8. And so when I put a 2 in, I get a 5. I'm just going right off my table here. So I got 5, 0, negative 3, negative 4, negative 3, 0, 5. Okay? And I'm going to go plot those points. The first one's at 2, 5, so I'm going to go right 2, up 5, 1, 2, 3, 4, 5, plot a point, then 3, 0, 1, 2, 3, then 4, negative 3, 1, 2, 3, 4, down 3, 1, 2, 3, then 5, negative 4, so 1, 2, 3, 4, 5, 1, 2, 3, 4, and you would repeat this for each of the points that you have in your table to finish getting that graphed. Okay. And then I'm going to draw my parabola through those points. All right? And again, don't make fun of me here because I suck at drawing with this pen. All right, you can make fun of me if you want. I can't hear you. There we go. There we are. So that's a nice parabola. Yeah. And we've seen this shape before. Hopefully you remember this from Algebra 1 where you've seen a parabola before. Notice again I put the arrows on the end just to indicate that this parabola keeps going up forever and ever. Okay. Alright, so here we go. I'm going to start working on my key points again. So we're looking for x-intercepts. Let me grab my pen here. So x-intercepts occur when the graph crosses over the x-axis. That's this horizontal line that runs across the graph. So we have an x-intercept here and here, and remember x-intercepts occur whenever y is 0. So I notice the y's are zeros here at 3 and 7. So I'm going to list both of those x-intercepts. We actually have two of them here. So we've got 3, 0, and then 7, 0. Okay. The y-intercepts, right? Remember, y-intercepts occur whenever x equals 0. Right? And if I'm looking at my graph, I didn't get my graph to go all the way over to the y-axis, but that's not a problem. I can find the y-intercept easily by looking for when x is 0. So I'm going to go over here to my calculator, and I'm just going to scroll up until x equals 0, and you might already see it there. So right there, when x is 0, y is 21. All right, so that was one of those values. It was a big value. I didn't necessarily put it in my table. I didn't even get it on my graph over here, but I was still able to find the key point using my calculator. Okay, and just remembering that y-intercepts always occur when x equals 0. All right, so that little trick can help you out. All right, minimums. Remember, minimum is the lowest point on the graph, right? So if we're thinking high to low, we're trying to get to the lowest point, which occurs right here. Okay, you can also find it in the table by finding the smallest y value. Right, and the smallest y value here is negative 4. So I'm looking at this point as being my minimum. So I've got 5, negative 4. Okay, last point here is the maximum, so this would be the highest point. But remember, we put these arrows on the end because we know the parabola never stops going up. So there is not going to be a maximum value here or a maximum point. So I'm going to put none. All right, last thing I'm going to talk about here is the axis of symmetry. And the axis of symmetry is a line, if you can imagine, a line that is going to be drawn on this graph in such a manner that if I were to fold over this line, let me grab a pen here, if I were to fold over this line, one side of that line would fold right on top of the other. So let me show you where the axis of symmetry is here. So for this parabola, I essentially want to try and fold this parabola in half. So you can see me drawing it in here, and this is where I would make that fold. So if I were to fold my parabola in half along this line, this part of the parabola on the left side would land right on top of the right side. That's how I know I have symmetry. Okay, so that line occurs right here. That fold line, that is your axis of symmetry, and that fold line passes through the x-axis here at 5. So when I describe my axis of symmetry, I'm going to say the axis of symmetry is at x equals 5. Okay. So now I want to go back to the first graph that we did just a minute ago. And remember, we were asking for an axis of symmetry on this one. Well, this one does not have an axis of symmetry. There is nowhere that I could draw that vertical line into this graph and get one side to fold on top of the other. All right, so for this one, we would say none. All right, guys, that's it for lesson 112. Go ahead and give the practice problems a try. Good luck.